Welcome to Climate Change in Rhode Island, part of the online series providing resilience education for planning in Rhode Island, or PrepRI. PrepRI is designed to enhance decision-making and resilience to current and future climate impacts to benefit the health, safety, and welfare of our communities for generations. My name is Caitlin Chafee, the Chief of the Narragansett Bay Research Reserve at the Rhode Island Department of Environmental Management, and I am one of the climate change experts guiding you through this module. I'm pleased to be joined by my colleague J.P. Walsh, who is a professor at the University of Rhode Island Graduate School of Oceanography. Together, we will help you navigate key concepts and insights related to climate change throughout this module. The PrepRI series is designed to enhance decision-making and resilience to both current and future climate-related impacts, which will benefit the health, safety, and welfare of our communities. By better understanding climate change and its impacts, we can better protect our communities. By the end of this module, you will be able to describe how climate change works, identify trends and impacts to your community, and express the need to plan for climate resilience. So why should we care about climate change and its impacts? We live, work, and play in areas that we value. Historic neighborhoods, productive fishing grounds, favorite beaches, and vibrant marshes are just a few of the many areas we want to protect as the climate changes. You've heard the term climate change, but have you thought about the mechanism behind it? Simply put, when we burn fossil fuels such as coal, oil, and natural gas for energy, we add large amounts of carbon dioxide or CO2 to the atmosphere, far beyond levels created by normal life processes. When sunlight passes through the Earth's atmosphere and is transformed into heat, some heat is absorbed by the Earth's surface and some is reflected back to space. However, some of that reflected heat is trapped by carbon dioxide and other gases in the atmosphere that act like a blanket around the Earth. This blanket is thickening over time, trapping more and more heat, warming our air and oceans. This warming leads to a variety of impacts which you'll hear about during the rest of this module. Observations show that there is a direct correlation between increasing carbon dioxide and rising temperature. Since 1880, the global annual average temperature has increased by more than 2.1 degrees Fahrenheit. 2/3 of the warming has occurred since 1975. The gray line on the graph shows atmospheric carbon dioxide, or CO2 concentration, rising at a similar rate as the temperature. The graph shows that temperatures are higher in some years than others, which is a result of different global patterns. While temperatures are trending warmer, we can still expect the occasional cold day. However, the trend is clear. Warming ocean and air temperatures have caused a loss of sea ice in the Arctic Ocean. Over the past 50 years, this loss of sea ice combined with a warming ocean have disrupted the Gulf Stream, an oceanic current bringing heat from the tropics to higher latitudes. In turn, this affects the behavior of our storm systems, leading to more extreme weather patterns. So what exactly is happening? Keeping the heat-trapping blanket and the increase in global temperature in mind, let's consider the impacts in Rhode Island. 2024 ranked as the hottest year on record for the planet. Locally, we have experienced a remarkable shift in temperatures over the last century. As seen in the graph, average daily temperatures are increasing. Over the past century, average temperatures in Rhode Island have gone from 47 degrees Fahrenheit in 1895 to 51 degrees Fahrenheit in 2023. Perhaps most striking is that the 10 warmest years have all occurred in the past 25 years. The warming trend is also reflected in temperature extremes. Summer days above 90 degrees have doubled since 1970. Increased temperatures mean longer, hotter summers with increased potential for drought and negative effects on human health. For example, limited tree cover in parts of Providence contributes to the heat island effect, when certain areas experience hotter temperatures within a city. Heat islands also tend to have poorer air quality, contributing to asthma and other environmentally determined health conditions. We're also seeing a steady increase in precipitation as warmer air temperatures allow the atmosphere to hold more water vapor. Since 1930, annual precipitation has increased by 8 inches. This is dramatic. Looking at the graph, notice the number of years since 1970 with annual rainfall of more than 55 inches. Rhode Island is also experiencing more intense precipitation events. The number of days per year of rainfall greater than 1 inch has doubled in recent decades. More intense downpours and an increase in roads, parking lots, and other impervious surfaces have resulted in more frequent flooding and, in some locations like the Patuxent River in Cranston, higher flood levels. While floods were infrequent in the 1940s, 50s, and 60s, the basin now often floods multiple times a year. Now I'm going to hand it off to JP.
So, what climate impacts are we seeing along the coast? Measurements taken at the Newport tide gauge show that sea levels today are nearly 1 foot higher than in 1930. Sea level rises due to several factors. Ocean waters expand as they warm, and glaciers and ice sheets are melting, adding water to the ocean. Sea levels are also affected by land sinking and changes in ocean currents. Sea level is rising faster in Rhode Island than the global average, and will continue to do so in the future. Relative to the year 2005, we can likely expect 1.5 feet of sea level rise by 2050, and potentially 6.5 feet by 2100. These projections, updated in 2022, are Noah's High Curve, which is the policy adopted by the Rhode Island Coastal Resources Management Council. Today's extreme tides give us a preview of our future. We should expect 1 to 2 feet of sea level rise before a new 30-year mortgage is paid off. More coastal areas will be regularly flooded by 2050. Shores that currently flood 3 or 4 times per year during extreme tides will flood about 70 times a year with 1 foot of sea level rise. Some marshes cannot keep up with this sea rise and will drown in place or be eroded. Other marshes may move inland, but roads and other development can prevent marsh migration. Models show that Rhode Island could lose approximately 50% of its salt marshes by mid-century. This loss will reduce ecosystem functions such as supporting nurseries for fish, helping to absorb floodwaters, and capturing and storing carbon from the atmosphere. Storm surge occurs when strong winds push water towards the shore, causing a rapid rise in water levels. During nor'easters, surges of 2 feet or more may last through several tide cycles and cause significant shoreline erosion. Hurricanes can potentially generate much higher surges, 10 feet or more above predicted tide heights. Storm surge can easily move coastal sediment, causing erosion and disruption to the built environment. And with higher sea levels during storms, the powerful waves can destroy houses, septic systems, and seawalls. Storm surge doesn't only impact ocean beaches and property, it also floods communities along the bay and backs up rivers, enhancing inundation landward. Erosion is expected to accelerate due to higher storm surge, resulting in greater damage to buildings and infrastructure. The effects of storm surge and sea level rise are modeled by an online mapping tool known as Storm Tools. Today, this road in Warwick experiences flooding during extreme high tides. The map on the right shows how 2 or more feet of surge or future sea level rise will flood more of the neighborhood. Increased sea level rise, more frequent and intense storms, and erosion will significantly impact shoreline access in Rhode Island. In addition to flooding and erosion of the shoreline itself, damage to parking areas and other facilities will further limit access. So, what can we do? Thankfully, many Rhode Island communities are already tackling climate change. Even with emission reduction efforts, the impacts of climate change are here now and will continue into the future. It is imperative that we plan, mitigate, and adapt as much as possible. When it comes to issues like flooding and erosion, Rhode Island municipalities are on the front line. Some are undertaking vulnerability assessments, and others are relocating or elevating critical infrastructure or restoring floodplains. All communities are required to include climate change and natural hazards in their comprehensive plans. Many are already implementing their strategies that you can learn about in other Prep RI modules. Thank you for viewing this module. Go to the Prep RI website to check out the resources document and presentation notes. Be sure to complete the brief quiz, get your certificate, and view the other modules. The Prep RI team acknowledges the support of statewide leaders, experts, and practitioners who helped to make this module a reality. And thanks to the Prep RI team for pulling this all together. This product was produced through the partnership of the URI Coastal Resources Center, Rhode Island Sea Grant, the Graduate School of Oceanography, and the Narragansett Bay National Estuarine Research Reserve. Thank you.